Hi, my name's Martha. I work with CyVerse. I'm going to show you how to use the NuclearDetector3D, which is an analysis module in BisQue. This is the BisQue dashboard. We go under Analyze and scroll down to NuclearDetector3D. The first thing we need to do is select an image to analyze. I'll choose one that's already been uploaded to BisQue. This is an image of retina, and in this image the Cy5 channel is detecting glial cells, so we're not interested in those. The FITC and Cy3 channels detect nuclei. Notice that this image has a Z dimension, so it is three-dimensional, which it needs to be for the NuclearDetector3D. What I'm going to do next is actually collapse the Z stack down into one plane by setting the intensity projection to maximum. This way we can see all the nuclei in one plane. Next thing that we need to do is determine the average diameter of the nuclei of interest. And I'm interested in the FITC stain, the green nuclei. So actually to make this a little easier, let's zoom in. When I zoomed in, the scale bar did change. So I'll just check a few of these and decide what we think an average diameter is. Sort of a small one. Okay, I'm going to use 7 as the value. So I will put 7 in for the nuclear diameter. Again, the nuclear channel that we're interested in for this example is the green one, the FITC stain channel. If we had a membrane channel, we could enter it. The membrane channel will is any channel that isn't correlated with the nuclear channel. If you have a membrane channel, it can help improve the definition of the nuclei. But we don't, so we'll leave it set to none. Then all we need to do is run the algorithm. The algorithms launch on a compute cluster at CyVerse, and this takes a little less than a minute to run. So while we're waiting for it, notice that in BisQue, the analysis modules all have some help documentation over in a right-hand panel, and this module even has a video tutorial embedded, so that's quite handy. So let's see if anything's going on over here. Not quite yet, but it should soon. Give it just another few seconds. Needs a little music in the background. Here we go. You see the algorithm beginning to run through its steps. And the analysis is done, so let's come down and look at the results. 34 nuclei were detected, and it's good to take a look through and see how this worked. So if we step through the Z stack, you see colored dots popping up where nuclei were detected. The bright yellow dots are nuclei where the algorithm is highly confident that it got it right. You'll see also blue dots, for example, on the red nucleus. That's very low confidence. It doesn't fit the criteria for these nuclei. An easy way to look at the results is to turn off the Sci5 channel and again set the intensity projection to maximum to collapse the Z-stack. Now we can see all the nuclei that were detected and use this slider bar to adjust the confidence level. So we see that if we set it to around mid-40s, that it's detecting the FITC labeled nuclei that may be of interest. If you know that you are only interested in the brighter green ones, then again you can determine what confidence level cutoff you should use by just moving the slider bar up and down. A couple of other things to note are that there is a plot that's generated. Again, this is the distribution of detection of confidence. You can also export the data from the analysis in CSV or XML or to a Google Doc. So if we take a look at the CSV data imported into an Excel spreadsheet, we can see the location of the nuclei in the image and the confidence value. So that's it for this demonstration. Thank you for watching.